just keep expanding it. First thing, if we're going to talk about graphing a rational function, you need to know what a rational function is. So when I refer to that, I'm just talking about dividing two polynomials. So you have polynomial on top, polynomial on the bottom. If you are looking, I think that's the first thing that's on that little handout that I posted on Classroom, isn't it? I don't have it pulled up in front of me. But I tried to type up all of the wordy stuff, so you didn't have to necessarily copy it all down in your notebook unless you really wanted to. So here we use just notation. Capital R usually stands for rational. P and Q are just polynomials. Now, if you're talking about this, if it's a fraction, we know that what cannot happen? Okay, the denominator cannot be 0. So that is the thing that will impact our graphs a lot on these. In a rational function, the denominator cannot be 0, so that would be one of the first things we look at, because we're going to find out a couple different things that can happen at those points on our graph. Okay, so that was the next little thing on there. Just says, with your domain, it can be anything except what makes the bottom 0. And those will be the places where the graph has some variation to it. So we're going to start our first example. I'm just going to give you a rational function, and we're going to practice finding the domain. So all we're going to be looking at is figuring out what makes the bottom 0. And your domain would be everything except that number or numbers. We will typically write this in interval notation. That's kind of been our standard for a while now. So let's take a look at this first one. So when you're finding the domain, you don't have to look at the top at all. We are just focused on the bottom. We know that that denominator cannot be 0. So that means x can't be -5. In interval notation, that's everything except -5. So that would be -infinity to -5, union -5 to infinity. So everything smaller, everything bigger, just not including that one number. Right, B. How could I rewrite the denominator to help me a little bit? Difference of squares. So neither one of those can be 0, so x cannot be -2 or 2. Now, we've talked about in the past, if it's just one number that x can't equal, I always told you I want the interval. If it was more than one number, I let you just list it. So because it's two numbers, you could leave it like that. Some of you did go ahead and put it in interval, which is awesome. If you do that, it's from infinity to -2, union -2 to 2, union 2 to infinity. Again, in this scenario, either of those is okay. Okay, but on part A, I want the interval notation. Right, C. If I set that denominator equal to 0, I can't factor it because it's a sum of squares. So if I set x squared plus 1 equal to 0, what kind of numbers are you getting? Imaginary. You get that x can't be a positive or negative I. If we're graphing, does that matter to us? No. So for our purposes, our domain is everything. Because you can't graph the imaginary numbers, so if no real number makes it 0, we have a domain of everything. All right, D. Does the bottom ever equal 0? can x not equal on this one? Since it's just one value, I want the interval, so negative infinity to 1, and then 1 to infinity. I do want to talk about e for a second. X squared minus 1. Over x minus 1. What could you do on top? Factor it. It factors into x plus 1, x minus 1, over x minus 1, and then what happens? And you get x plus 1. But here's what I need to tell you. These are not equivalent. Why would that be? When we factor in it canceled, what would be the difference? What did we say the domain of this one was? It's everything except 1. What's the domain of x plus 1? Negative infinity to positive infinity. Okay, so that is something we will talk about when we graph these. When things cancel out like that, there is a slight difference on the graphs of those. What it is, the original one, x can't be 1, and so it would actually put an open circle on the graph. The second one would just be a line. So just be careful when I ask you to graph, you can't reduce everything and then graph. We have to look at the original when we're deciding what our graph looks like. Your graphing calculator, that is one flaw with it. It will not show you when something cancels out like this, because it does automatically reduce and then graph it. So it's not going to show you when you have an open circle on your graph. That's something we're going to have to figure out. So we'll be working with that over the next few days. We're not going to get through this section in one day by any means. It'll take us a little bit. Okay, any questions so far? So, next thing I want to mention, this is back to your little handout with definitions. When we graph these things, we are going to have asymptotes. Asymptotes are lines that our graph is approaching without actually touching. So usually we draw them as dashed lines, so you're just getting closer and closer without ever actually touching it. You have probably, well, we've seen some vertical asymptotes before when we graph like 1 over x. But we've probably never really talked about the horizontal, or the third type is oblique. Sometimes this one is called a slant asymptote. So oblique or slant is just any other line, not a horizontal or vertical. So something like y equals 2x plus 1 would be an oblique asymptote. It is possible for a function to cross a horizontal or oblique asymptote, but it will never cross a vertical asymptote. Alright, so asymptotes in general, those vertical ones are going to happen when the bottom of the fraction is 0. And that's what we're going to be looking at in just a second. Horizontal and oblique, we're going to have a whole set of rules about when we have those things. So first, we're going to go with a function that you've probably seen before. We're going to talk about the reciprocal function, 1 over x. Graph it, look at the asymptotes for that function, and then we will extend this idea. Everybody have down what they want from this? Okay, so let's graph f of x equals 1 over x. We know if we don't know what a graph looks like, we can always make a t-chart. Can you plug in 0? No, it makes the bottom 0. If I put in 1, I get out 1. If I put in 2, I get 1/2. If I put in 3, I get 1/3. What would happen if I plugged in 1/2? 1 divided by 1/2 would be what? 2. So 1/2 would give me a 2. 1/3 would give me a 3. Will I ever do 1 divided by something and get 0 for an answer? Nope. It'll get closer to 0, but never actually equal it. So it's going to look kind of like this. We could plug in some negatives. If I put in -1, we get -1 out. If I put in -2, get -1/2. If I put in -1/2, I get out -2. So it's kind of the same thing just over here. So the domain of this, what can x not be? 0. So our domain is -infinity to 0, union 0 to infinity. Our range, if we look at this graph, what is the one y value we never hit? 0. So our range actually turns out to be the same thing. Vertical asymptote is the vertical line that you are approaching without actually touching. It is a line, so it needs an equation. Vertical line is always x equals, so that would just be x equals 0. Horizontal asymptote is the horizontal line we approach without crossing, so that would be y equals 0. Is that one okay? I would also like to do the reciprocal square function, 1 over x squared. So what can I not plug in again? 0. So let's try the 1, the 2, and the 1/2 again. So if you put in a 1, 1 squared is 1, 1 over 1 is still 1. If I put in a 2, 2 squared is 4, so we get 1/4. If I put in a 1/2, 1/2 squared is 1/4, 1 over 1/4 is 4. So this piece kind of looks like this. We're never going to get 0. If we plug in some negatives, what happens when you square a negative? It becomes positive, so we get the same points out when we put in a negative. So it would look like this. So what's my domain? Can equal 0. So infinity to 0, union 0 to infinity. The range, what y values are we getting? Everything positive, right? So it's just 0 to infinity. Parenthesis on the 0 because we never actually get 0 out. Vertical asymptote. And a horizontal asymptote, y equals 0. Good. All right. What I'm going to do now is put a graph up, and we are just going to look at that graph and tell what the asymptotes are from the graph itself. So some of your homework questions tonight are going to be like this. They're going to give you a graph and just say, find all the asymptotes in that. I'm asking a few more questions right now. This is good practice for us. To do domain and range. So domain is talking about the x. So it's going from left to right. What is the one x value I'm not hitting? 2. It's like, that's our vertical asymptote. Where's our horizontal one? Okay. So our domain then is everything but 2. So it would be negative infinity to 2. Union 2 to infinity. Range is talking about your y's. What y values do we get? Okay, intercepts. X-intercept means where do you cross the x-axis? X-axis is, x-intercept is 1, or if you wanted to write an order pair, it'd be 1, 0. Y-intercept, we hit the y-axis at 1/2-ish. We can't tell for sure because I didn't give you an equation. So, or if I gave you an order pair, it'd be 0, 1/2. What is the horizontal asymptote? Y equals 1. Make sure it's an equation. Horizontal is y equals. Vertical? Good. Oblique, do we have a third asymptote here? No, so there is none. An oblique asymptote would look something like this. So you might have a graph that did something like this. So you can see there's that slanted line we're approaching, not a horizontal or vertical one. Okay, so far so good? So now we need to talk about how we are going to find all of these things from the equations. It's one thing if we have the graph in front of us, but ultimately we need to be drawing the graph, so we have to get it from the equation. If you are looking on that note summary that I posted on Classroom, it's right there. So we have a long process here. We have the 3 different types, so we need to talk about how to find each of them. In a rational function, we're just dividing 2 polynomials. To find the vertical asymptotes, that's x equals a number, and that's going to come from the denominator. So whatever makes the denominator 0 will be a vertical asymptote. The horizontal and oblique, there are rules, and those rules are based on the degree. Okay, so if the degree on top is smaller. So I'm going to kind of show you by example why this works out to be the way it is. Let's say I had x plus 1 over x squared. Can we all agree that the degree of the top is smaller than the degree of the bottom? If you tried to divide this, remember your long division days? The top goes on the inside, the denominator goes out here. And then you divide. Can you do x divided by x squared? No. We get a 0. It won't go in at all. So when the degree on top is smaller, it is an automatic y equals 0. If you were to try to divide those, you can't because the degree on top or on the top is smaller. If they have the same degree, so let's say I gave you 2x over let's do 6x squared over 3x squared minus 1. If you were to try to divide that, the 6x squared goes here. The 3x squared minus 1 goes out here. And when you do this long division, you divide 6x squared divided by 3x squared. And what does that give you? The x's drop and you're left with 6 divided by 3, which is 2. So if it's the same degree, you divide the leading coefficients. If the degree of the top is bigger, so like if I had 5x to the third plus 1 over 2x. Okay, when you go to divide this, to be a horizontal line, it has to be y equals a number. When I divide this, 5x cubed over 2x, won't I still have x's with it? Yeah, so it's not horizontal then. Your asymptote is essentially, if you were to do the long division, it's the quotient minus the remainder part. Okay, I'm trying to give you some kind of justification for why it is what it is. It's really kind of because of the resulting calculus why this works out. What you guys have to know is the rule. So I'm not going to ask you to prove to me why the rule is what it is. What you need to remember is if the degree on top is smaller, it's an automatic y equals 0. If they have the same degree, we will divide the leading coefficients. And if the degree on top is bigger, it is not horizontal. So that's what we need to know for now. Let's practice just looking at some equations and finding the asymptotes from those. I want, this first slide, all I asked for was the vertical asymptotes. So how do we find vertical asymptotes? We don't need to. Look back at what we just talked about. How do we find a vertical asymptote? Look up above it. Yeah, it's what makes the bottom 0. Vertical is what makes the bottom 0. So if I were to factor x squared minus 4, that breaks into x plus 2, x minus 2. So my vertical asymptotes, what numbers make the bottom 0? So we have 2 vertical asymptotes. Is everybody with me right now? You can have multiple vertical asymptotes. The horizontal and oblique, you'll only have 1. Let's go ahead and do the horizontal asymptote on this one. What's the degree of the top? And the bottom? 2. If the degree on top is smaller, it is
0.
Horizontal y equals 0. Alright, so let's look at this one. What is my vertical asymptote?
1.
X equals 1. And you do have to write them as equations. Horizontal, what is the degree on top?
1.
And bottom? 1. If it's the same degree, you divide the leading coefficients. So this is like 1x over 1x, so it would be y equals 1. 1 divided by 1 is 1. C. What do I need to do to find my vertical asymptote? Set the bottom to 0. We had this one come up a little bit ago, didn't we? What kind of number am I going to get? Imaginary. So what does that tell me about my vertical asymptote? Yeah, the domain is all real numbers. That means there is no vertical asymptote. Okay, degree of the top, 2. Degree of the bottom. So my horizontal, you divide those leading coefficients, so it's 1x squared over 1x squared, so it'd be y equals 1. Alright, G. What do we need to do here? Factor. So the bottom would break into what multiplies to negative 21 and adds to positive 4. So what are the vertical?
-7, 3.
And what would my horizontal asymptote be?
1.
Yep. Again, it's same degree on top and bottom, so it's just y equals 1. Okay, let's talk about the third type, oblique asymptotes. Oblique asymptotes are just a line that is not horizontal. So y equals mx plus b. You have to have an x to the first. Think about my rationale for the others. I was talking about doing long division. If you're going to divide and just get an x to the first, that means the degree on the top has to be 1 bigger than the degree on the bottom. So like an x cubed over x squared, an x to the 5th over x to the 4th. So the top degree is 1 bigger. That means oblique. Could I have both a horizontal and an oblique? Think about when they happen. I said if the degree on top is smaller, it's horizontal. If it's the same degree on top and bottom, it's horizontal. We have oblique when the top is 1 bigger than the bottom. So could it be both? No, it's an either or. If the top is more than 1 bigger than the bottom, then there's no horizontal or oblique. So we might have horizontal, we might have oblique, or we might have none. You'll never have both of those. Alright, so that's the last piece we're looking at today. We're just going to practice identifying those, maybe. So we know it can be one or the other. We're just going to figure out what each of them is. What's the degree on the top here? 4, just your highest power of x. The degree on the bottom is 3. So the top is 1 bigger. That means it is oblique. Now, unlike horizontal, we don't just have rules. We have to actually do the division to figure out what it's going to be. So we're going to do long division. Out here, I put my x cubed minus x squared. If you want it, you can put a 0x for a placeholder. Here we have a 3x to the 4th. You could put a 0x cubed minus x squared. Zeros are optional. It just kind of helps us organize what we're doing here. The nice thing is we don't have to do the full division, guys. We just need to get the equation of alignment. Y equals mx plus b. So we need 2 terms. To start, you divide the first ones. So what is 3x to the 4th divided by x to the 3rd? 3x. So we've got a 3x here. Then you multiply. You have to take 3x times all of this. So 3x times x cubed is 3x to the 4th. 3x times negative x squared is negative 3x cubed. I'm just distributing the 3x through here. So 3x times 0x is 0x squared. 3x times 1 is 3x. Okay, I know we're kind of struggling here, going back to our long division days. Do you guys remember what we need to do with this? Subtract it off. So if we distribute a negative, the good news is, guys, we're really almost done here. These drop. You have 0x cubed plus 3x cubed. Negative x squared minus 3x. Okay, so then we just have one more step. We're back to the divide step. What is 3x to the third divided by x to the third? 3. That's all we need, because we're trying to get a line, y equals mx plus b. We've got it, 3x plus 3. So we have an oblique asymptote. It is y equals 3x plus 3. So the oblique, that's probably going to be the one that we have to work on a little bit, because we have to go back to that long division. I'm going to put 2 up here. I want you guys to decide horizontal or oblique and find them. So here are your 2 problems. So this one, the degree on top is 2. Degree on the bottom is 2. Same degree on top and bottom means we divide the leading coefficients. So 8 over 4, y equals 2. Alright, this one, degree on the top is 1. Degree on the bottom is 1. Same degree, so you divide the leading coefficients, so 3x over 1x is 3. Alright. We're kind of running short on time. I want to do one more oblique and then I'm going to stop, okay? So what's the degree of the top? And the bottom? 2. So the degree on top is 1 bigger. That tells me long division. So we have on the outside the x squared minus 5x plus 6. Inside we have x cubed. If you want, you can put the 0x squared, the 0x, and the minus 8. Okay, so remember, we don't have to do everything. We just have to get the equation of our line. So you start with divide. What is x cubed divided by x? X. Then you multiply. So you take x times all of this. So x times x squared is x cubed. Minus 5x times x is 5x squared. 6 times x is 6x. Then what do we have to do? Subtract all that off. So if you distribute a negative, those cancel. We get 5x squared minus 6x. You can break down your minus 8. We are 1 step away. 5x squared divided by x squared is 5. So our oblique asymptote is y equals x plus 5. Okay. We are definitely not done with this. We are still working on it tomorrow. What I'm going to do, I know I haven't left you a lot of time to work on your homework today. I'm giving you homework today. Tomorrow I am going to add more to this assignment, but I won't collect any of it until Monday. Okay, so that's my trade-off for talking too long today. I'll give you a little extra time to get that done. So, where do I have it? Your assignment. Most of these, like 9 through 16, you're just looking at some graphs and answering some questions. 37 through 45, you're just writing down the asymptotes. 52 and 54, there's a matching one. There's looking at a graph and writing out the asymptotes.